Okay, so today we're going to talk about some more identities. You are going to need both of these for homework tonight. The tangent one actually we don't use as often, but you do need to be aware of it. So these are pluses and minus identities when you're trying to add two things together inside a single trig function. So if you have, again, you look at this, it says sine of x plus y, okay, equals the sine x, cosine y, is cosine y, sine x, okay? So you see these again, I'm not expecting you to memorize these. In fact, on all the examples today, I put this back up here so we can look at it. You may want to write it down so you have it somewhere. At some point, I will probably have a sheet with all of the identities that I'll copy and laminate so you can have something in class and on tests and quizzes and things like that. But right now, this is what it is. So, so we're going to use this one today. We have 4 examples today and several examples tomorrow. We're going to spend 2 days on this section. So these are interesting problems. I like this. It started out with this type of a problem. It says, find the cosine of pi over 12. Now, if you look at your unit circle, there is no cosine of pi over 12. So how can we make it so that we can find the cosine of pi over 12 with no calculators, all right, and get exact answers? So what we're going to do is we're going to look at fractions, okay? Now, I want you to realize that if I change this fraction to a plus or minus problem. Now, let's just think for a second with the number 12. We're not even going to look at the fraction for a moment. I just want you to get the idea of where we're coming from. And let's not even use the number 12. Let's use the number 5. Okay, another way I could write the number 5 is 2 plus 3. 7 minus 2. All right? 10 minus 5. There are other ways I can write the number 5 than just 5. Now, fractions work the same way. The problem with fractions is that you have to have common denominators. So with this one, I'm going to rewrite it, and just bear with me for a second. You may have to think for a little bit on these problems on how you're going to get what you need. But I'm going to do 4 pi over 12 minus 3 pi over 12. Okay? And I want you to think for a second about why this is the same thing. 4 minus 3 is 1. Common denominator is 12. All right? Now, the reason I picked these numbers is because 4 pi over 12 reduces to pi over 3. 3 pi over 12 reduces to pi over 4. So I'm going to rewrite this as cosine pi over 3 minus pi over 4. Okay, now I can already see some of you going, wait a minute, this seems too hard. Okay, this is probably the hardest thing we're going to do today. So if you're having trouble with this one, that's okay. Bear with it. Okay, go through the examples, go through the rest of them, and if you need help on these problems tomorrow in class, I'll help you with these problems. All right? But it's weird because the hard ones come first today. So now that I have this, I can rewrite this using my formula, and I didn't put it on this one, I should have. Okay, the formula of cosine with a minus sign in it is cosine x, okay, so cosine pi over 3, okay, cosine y, cosine pi over 4, plus, ironically, it's a minus problem, but it's only uses plus, sine of x, sine y. So now I have this problem. Okay, I've used my formula to rewrite it. Now I know, based on my triangles, okay, I'm not going to rewrite the triangles, that cosine of pi over 3 is 1/2. Okay, cosine of pi over 4 is root 2 over 2. Okay, cosine, or sine of pi over 3 is root 3 over 2. And sine of pi over 4 is root 2 over 2. Okay, so basically that reduces to, if I multiply, root 2 over 2, or sorry, root 4. Root 2 over 4 plus root 6 over 4, and that equals root 2 plus root 6 over 4. And it should go well. Okay. That's the answer. So I don't go any further. I don't have a calculator. I'm doing this all in my head and all with the knowledge that I have of my triangles. All right, so that's example 1. All right, so again, this was the hardest type of problem because you have to think about these fractions. Okay, so from here on out, problems are given to you fairly straightforward. Okay, so let's look at the next example. All right, so this is, now I have the directions in here because I pulled these problems out of the homework. All right, so so that you have, so that they look just like the homework problem, so there's no panicking. All right, so it says rewrite the expression, the given expression in terms of sine x and cosine x. So basically, we're just trying to stretch it out. So when we have cosine x plus pi over 2, okay, that becomes the cosine of x, cosine of y. Okay, now y in this case is pi over 2. Now, ironically, this is a plus sign. I'm going to use this as a minus. All right. Also, these identities, let me finish the problem and talk about that. Okay, minus the sine of x, sine of pi over 2. Okay, so cosine of x is just going to stay cosine of x. But I know that the cosine of pi over 2 is 0. All right. Sine of x is going to stay the same. And the sine of pi over 2 is 1. All right. So this becomes 0 minus sine of x. And that's my answer. All right. So let's talk for a moment about these identities. We should have done this earlier. All right. There are proofs that show that these work. All right. I do not feel that it is beneficial for your time or mind to show you those proofs. If you look back in your book in section 9.2, they do show you the formal proofs. If you look at it and you're still having trouble with it and you want to come ask some questions, I'm available before or after school or during lunch if you have questions on the proof itself. Okay. Other than that, I'm just going to ask you to believe me that they do work. At some point we may prove them, but right now I just want to know that they. You just need to be able to use them. You don't need to memorize them, but you need to be able to use them. All right, moving on. Next example. Okay, so this one. Now this one has degrees in it. This is an interesting problem because we're going to work backwards. It says simplify. Simplify. So I'm going to look at this sine 37 and sine 53 minus cosine 37, cosine 53. Again, okay, problems that we don't really know, okay, that we can use calculator for, but I don't want you using calculator. I want you to do it on your own. So let's look at what this matches. So I have sine. Sine. So we're going to look at the ones that have sine in the problem. Okay, look, there's two of them. There's this one, and there's that one. Okay, and I have a negative cosine. All right, so cosine. So I have cosine here, cosine here. So neither one of them had negative cosine. All right, but one of them has a negative sine. So what we're going to do is we're going to actually rewrite this so that we can use one of these two. So I'm going to factor out a negative 1. I'm going to go negative 1, sine, now it's negative, sine 37, sine 53, and now it's positive, cosine 37, cosine 53. So now I've changed my negative where my negative is, so I can use the cosine x plus 1. So it's a negative times cosine of 37 plus 53. Okay, 37 plus 53 is 90, so it's a negative cosine 90. Now what's interesting about this is the negative doesn't matter, because the cosine of 90 is 0, so my answer is 0. Alright, one more example. Okay, so now this is probably the longest one you have to do, and again, the problems tonight are not too hard. Tomorrow, they probably will be on the harder side. I'm going to move this up just a little bit so I have room to work. So sine of x plus y minus sine of x minus y. So basically, we're just going to stretch it out and see how we can simplify. All right. So sine of x plus y is sine x cosine y minus cosine x. Oh wait, no, I mean plus cosine x sine y. Okay, minus, that's minus is important. Okay, sine x cosine y minus cosine x sine y. All right, so let's go ahead and I'm going to, without rewriting the whole thing, I'm going to change signs here. So I'm going to make this a plus, this a minus, and that becomes a plus. All right, so the parentheses aren't necessary at this point. So I'm looking for ones that match sine x and cosine y, so I can cancel those out, because one's positive, one's negative. These two are both positive, cosine x sine y and cosine x sine y, so I have 2 cosine x sine y. And I am completely simplified. There's absolutely nothing else I can do. So that is it. Good luck with your homework.